let's get started. Officially want to welcome you to our webinar today. My name is Isabel Dom. I am the Senior Digital Marketing Manager with Agritecture. The conversation today is brought to you by Surna, and we're going to be the discussion is going to be led by Brandy Keene. Before I hand it over to her, who will lead it, just want to say thank you and welcome to everyone. And to get us going, please introduce yourself on the group chat. Tell us where you're tuning in from. And just a reminder, we are going to have time at the end to answer some questions. So do use the Q&A feature if you have any questions for the panelists. And also just big disclaimer, because this is always the first question that pops up, it is being recorded. The webinar is being recorded, and we are going to email it to you directly after we wrapped up. And so with that, I am very pleased to hand this conversation over to Brandy Keene.
Thank you so much, Isabel. Hi, everybody. Good morning, good afternoon, good evening, depending on where you're joining us from. My name is Brandy Keene, and for those of you who don't know me, I am the co-founder and senior technical advisor at Surna. Surna Cultivation Technologies is an architectural and mechanical, electrical, and plumbing engineering company with special expertise in climate control systems. We also implement climate control equipment and control systems in our cultivation facilities. Really, really happy you guys all joined us today. Excited to dive into this subject. Right now, I think that in the controlled environment agriculture industry, the conversation around reducing operating costs has become a little more compelling than it may have been in previous years. And in this particular subject matter is pretty relevant to that conversation. Joining us today, we have Steve LaFale with Tecogen. Steve is the Vice President of Business Development at Tecogen. They've been manufacturing electrical and mechanical CHP systems for about 40 years, so a little bit of experience there. And they've also got a large network of factory service, and they've become really engaged in controlled environment in the past years as cultivators look to reduce those operating costs. We've also got my colleague, Kenneth Lowshelder, joining us. Kenneth is the Vice President of Operations at Surna. He's a mechanical PE, and he oversees the mechanical, electrical, and plumbing designs, as well as the implementations of climate and control systems at our client facilities. Understanding how all the systems in cultivation facilities really interact with each other is a big part of his role at Surna, so he's really knowledgeable about the applications of the systems. Last but never least, we have Jim Kelly with Cultivated Power. Jim is a long-term business executive, lots of experience in finance, corporate development with an emphasis on energy. He's actually a certified energy fellow. His company, Cultivated Power, provides CHP and climate control systems to horticultural industry, industrial industry, and the hospitality industry. So really knowledgeable panelists, really excited to have everybody joining us today and looking forward to the conversation. So we're here today to talk about using combined heat and power in cultivation, indoor cultivation. Really, there's a lot to cover. An hour is not enough time. So we're going to keep things kind of high level, touch on the major subjects that we need to talk about. But I want you guys to know, too, that my co-presenters and I do have a white paper that does a very deep dive into the subject that will give you some links to download that for free later if that's something that you're interested in exploring further. One of the things that I think has, as I mentioned before, that's become really increasingly important to the cultivation industry is reducing operating costs. And historically, implementing combined heat and power into cultivation facilities has been considered primarily when access to energy has been problematic, right? But I think that cultivation operators haven't considered the financial benefits that they may see from the use of combined heat and power in cultivation facilities. And that's one of the things that I want to make sure that we talk about, is that there are some really good reasons to implement it, even if you do have grid power available. So to kind of start us off and talk about that, Jim, can you give us some kind of high-level insights into how cultivators can benefit financially from using combined heat and power at their facilities?
First off, you have the multi-pronged ability of combined heat and power to do that. Provide heat, provide power, and for all horticultural activities, provide CO2. Okay. And if we go totally crazy, we can work on water. That's outside the scope of this. So let's talk metrics at a very high level. Okay. With current gas pricing and with the cost of large scale generation equipment, we can generate power in the 4-cent range. Okay. On top of that, we'll add all the ancillary costs, cost of operating, people, etc. to that. That adds 2, sometimes 2.5 cents to that. So that's saying at current pricing, we can generate between 6 and 7 cents per kilowatt hour. In some states, that is okay. In other states, that's fantastic.
That's it. Yeah, here I pay 11 cents, right? So that would be a big and the way that they generate that power is typically by burning natural gas.
Correct.
Right. Okay.
Okay. And we along with the Tecogen people have come up with methodologies to clean up that combustion of natural gas, so much so that we can then use that exhaust in the systems for CO2. Mm-hmm. So it's still a very green approach, because you're not using boilers now. You're getting all your heat from your own system.
Got it. So we have the reduced cost of actually producing electricity, which 6.5 cents a kilowatt is, substantially lower than grid power in a lot of locations. Not every location, but probably most, right?
Yes.
We have the production of heat as a byproduct of producing electricity, a substantial amount of heat that can then be captured and reused and applied in the cultivation facility in some ways that we'll kind of get into in a bit. And then you have the potential of also capturing and cleaning and reusing CO2. So instead of that CO2 going to waste, you have the potential cost savings associated with using waste CO2 to supplement growth in the cultivation facility, kind of effectively making it kind of a tri-generation system, right? Is that the terminology? Got it.
I think you'd want to add to that the effect on demand charges, Jim, because isn't that basically removed from the equation?
Yeah, so we often think about our 10 cents an hour cost of kilowatt hours, but demand charges, etc., can add 2, 3, and 4 cents to that number very, very easily, especially with the kind of demands that these large facilities bring on.
Yeah, and what Jim and Kenneth are talking about is you kind of get a flat, cost of your electricity, right? But then you're also effectively taxed on peak use, time of use, that sort of thing, which can actually drive your cost of energy substantially higher than your actual, cost of getting the energy. So I don't think there's anybody in the industry at this point who doesn't recognize the need to kind of minimize operating costs to stay competitive. But the reality is that we are all still kind of operating on limited capital budgets, right? And in a lot of cases, implementing CHP might be more capital intensive than grid power. There are some financial incentives, though, that help to kind of mitigate those costs and make that more affordable and kind of speed up that payback period. Steve, can you elaborate on what some of those incentives are?
Yeah, sure. I think the big one right now that's getting a lot of attention is the ITC investment tax credit that was recently upgraded, if you will, by the IRA that just passed, Inflation Reduction Act. So CHP systems get between 30 and 40%, depending on if you meet the domestic requirements, 30 to 40% tax credit. So that's huge. And of course, 280E can pose a little bit of a wrinkle, but most of the customers we've talked to have figured out ways around that, even in the cannabis space. But one thing I'd like to mention about that too is that the tax credits are now fully transferable. That was a stipulation that the IRA brought into the equation that we didn't have before. So the transferability is huge. You could transfer it right away for cash versus trying to think about, okay, am I going to have a tax liability? How profitable am I going to be in the first few years of this business? You can carry it forward, the credit, for up to 5 years, but I think a lot of people are looking at the transferability option as a really attractive way. And there's going to be a small, penalty. Maybe we're hearing 80 to 90 cents on the dollar, but that's still a huge benefit. And then on top of that, you have utility incentives in many states. A lot of the states that we're hearing about in the cannabis, New Jersey, Maryland, Pennsylvania, it's a little spotty, but there are often, depending on where you are, those utility incentive programs those are additive to the ITC. The ITC is obviously federal, every single state that's applicable. So those are the two big benefits that can help you reduce your upfront costs. I don't know if Jim wants to add anything to that.
Yes, Steve, I'll go on a little bit more. From an accelerated depreciation standpoint, you can basically get 100% depreciation of these assets in the first year, again, if you have those tax benefits. There are other programs that it does qualify, and give you some idea. You mentioned Maryland, my favorite state. We got $3 million worth of tax incentives against a $4 million project. So there are some very, very good utility programs out there.
There are, and I just to add to to the ITC, and I see your questions coming in the chat, guys. I love it. Please continue to send me your questions. I promise we'll get to them at the end. So, but send them when you think of them. But back to the ITC, that applies not just to the CHP system, right? Doesn't it apply to the entire installed system? So if you've got a mechanical or HVAC system that's connected to that, isn't there some credit there?
Yeah, it would all qualify as energy efficient project. And so therefore, yes, you would wrap the whole thing together. Lighting can be, LED type lighting can also be wrapped up in that.
Wonderful. So, when you guys are thinking about this, don't just kind of get a price for the systems and think that that's the end all be all, right? There are some pretty substantial, incentives to adopt systems like this. So I want to move on to, the use of the hot water in these systems and the use of that waste heat. It produces a substantial amount of heat as a byproduct. Think about your car motor, right? It's warm, right? It's hot. And so when you use these motors to produce energy, then you've got the ability to capture that heat and reuse it elsewhere in your facility. In indoor cultivation, in most cases, the best use of that heat is to apply to your mechanical system or your HVAC and dehumidification system. Kenneth is our resident expert on all things HVAC. Kenneth, can you give us a summary of the kind of types of mechanical systems that are used in cultivation facilities, the challenges, of climate control there, and then the best use of that heat in most cases?
Yeah, because we're dealing with heat and trying to use the heat that's coming from the power systems. Some of the most typical HVAC systems we see in the industry today, especially on smaller systems, aren't necessarily going to be applicable to using with to pairing with these types of systems. So especially like DX based systems, VRF, with standalone dehumidifiers or rooftop units, integrated DX purpose-built systems, standalone DX. There's not a good use to apply the heat to those systems. So typically, you're looking at hydronic based chiller systems with hot water reheat. So however, there's a lot of different ways to mix and match, you know, depending on how much power you're trying to produce, how much power might be already available. You could do these systems in a number of ways. You can use heat to power absorption chillers to produce chilled water effect, or you can generate power for electric chillers and use your heat for hot water reheat, as well as the option that Tecogen offers to just power chillers directly with gas engines as well. So there's a lot of different ways to go about doing it, but you're typically you're going to be looking at hydronic systems, with the caveat there that desiccant could be applied as well. So really there's a lot of options, and it's going to depend on you know, really what you're looking at from why you're implementing the CHP to begin with, and then what you're looking at in terms of, you know, redundancy and laying out your HVAC system.
So you know, Stephen and I were talking about this earlier about folks that reach out to him, you know, sometimes thinking about retrofitting an existing facility with CHP, or if it's something that you didn't do at phase one, and you know, you might want to go back and redo at a later date. Steve, what are some of the things that folks need to consider when they build their first facility to make sure that it's, you know, most conducive to that retrofit, you know, along those same lines?
Yeah, sure. I think we're big advocates of hydronic based systems, chill water and hot water. You know, it leaves the opportunity to do CHP later. And we talked about some of the capital constraints. You may not be able to do it on day one, but you should think about leaving the optionality in the future. I would say 80% of the CHP systems that we've sold over 40 years have been retrofits. I mean, it's human nature is you don't always make the best decision, or you can't always make the best decision on day one. So thinking about leaving that option open, and as Kenneth just mentioned, you're really kind of stuck if you put in a DX based system. It's near impossible to retrofit in and use the waste heat. So I think if you start off with chill water and hot water reheat, you do have that opportunity to do CHP later once you get some cash flow going and get your business up and running. So that's really important. We give people a lot of bad news that we can't help them reduce their costs because of the systems that they chose, you know, originally. So
yeah, meaning that if they haven't started their facility with a hydronic system, then, you know, retrofitting with CHP to really capitalize on everything that it can offer would also kind of require an HVAC retrofit if they have a DX or a forced air style.
right, which isn't impossible. We've seen people do that, but it's quite disruptive, and it's challenging to do. You know, so
it is.
So let me go on.
Go ahead, Jim.
Brandy. Yeah, one more point on that. There clearly are elaborate DX systems that allow their own waste gas reheat or utilizing CHP for waste for reheat. When we've seen those kinds of systems installed, the level of control is not the same as with a hydronic system, okay? Because the way they operate, they move in and out of a range to turn compressors on and off, okay? In a hydronic system, your compressors are always going, and all you're really doing is moving and modulating fans to move chilled air into those facilities. And so therefore, the control in the hydronic systems that we've operated have been in that less than 1 degree F range, which is, you know, very, very critical when you're growing a critical crop, such as most of these clients are.
It is, and you know, it's interesting when we start getting into the climate control systems in these cultivation facilities. You know, that's something that we do a lot of, and you've got clients who have, you know, I just want the cheapest, fastest thing that we can do, or I want the tightest, you know, most efficient, you know, tightest control you can possibly get. And there's a wide range of things that you can apply, you know, within that spectrum. But I think that we would agree that we see the tightest control in a dialed in hydronic system where everything is really modulating. We've got some cool facilities that we can kind of log into and look at those systems and see things being controlled, like you said, very, very tightly, which is really important to a lot of cultivators, not all of them, but a lot of them. So we've talked a lot about the kind of financial benefits and the ways that we can use the various energy streams, right, that come out of the plant. I want to kind of move on to some of the practicalities of implementing these systems in cultivation facilities. There's a lot of coordination, right? There's a lot of coordination among design disciplines. There's a lot of coordination with the utility, a lot of coordination with the AHJ. We're going to touch on a couple of those here. We do a much deeper dive in the white paper. Again, if you're really considering doing something like this, I would absolutely go check that out. Jim, can you kind of summarize for us some of the coordination requirements for the CHP provider around the gas, the electric utility, and then the whoever has jurisdiction regarding air quality?
Yeah, you need partners that can help you with both sides of the utility, okay? To understand what you're going to do with the electrical utility. Are you going to stand alone? Are you going to bring on power from that utility at a later point in time? And then ultimately, are you going to be set up to provide them power, okay? And that's especially critical in greenhouse type applications because you have lots of power available when the grid needs power, okay? So you have that. You need to work with the natural gas companies to make sure that you have access to the gas. This is a very low power or a low pressure approach to natural gas, but it is a volume approach to natural gas. So you want partners that are used to doing that and then taking you to the next step, okay? And putting in futures contracts for natural gas. We had one client that was still operating on $2.80 per MCF gas when gas hit $9, 2 years ago. So that's kind of the financial aspect of doing that, okay? And so therefore you need people that understand, dealing with both sides of the utilities, making them your friends, and therefore you have a very good relationship moving forward.
And would that typically be something that the owner would do, those kinds of things, or is that something that the CHP provider would get involved with, right? Because it seems like, if I'm an owner of a cultivation facility, that seems intimidating, right? Understanding what all these requirements are and how you interact with these with the utility.
Your contractors or your CHP providers are probably going to do 70+% plus all the legwork. And then when it starts getting critical, you bring in the CFO of the organization to discuss certain aspects of it, okay? Such as accruals, such as natural gas contracts, etc. But everybody on this call knows how complicated our engineering calls are. And so therefore, yes, it does take a lot of touch points to keep all of this moving forward.
Yeah, it does. So much coordination, but it sounds complicated. The idea is work with folks who know what they're doing, right? We're not the only ones who understand how this works. There are other ones out there, but the really key point, I think, is to ensure that the folks that you're working with have really significant experience in the implementation of these types of systems, specifically in cultivation facilities, right? Because that will save an enormous amount of heartache and oops down the road, and that you've got a group that can kind of guide you through what all that coordination really looks like and what needs to be done and when it needs to be done. Right? It doesn't have to be complicated for owners. It's complicated for the rest of us, right? But we need to, like I said, that it's important that you work with folks who understand that complication and how to navigate, how to get this implemented for you. And kind of along the same lines of that subject, Kenneth, the engineering coordination is pretty in depth, right?
Mhm.
Everyone is communicating with everyone out, the electrical engineer, the CHP provider, and designers, the mechanical engineers, the architects, the civil engineers, right? Everyone's kind of working together to implement these systems. Can you give us an idea of the kind of information exchange that happens between the mechanical engineer and the CHP provider, and the kind of criticality of that communication?
Yeah, for sure. So to start with, at the beginning of the project, the mechanical engineer is looking at the load side of the use of the rooms. What are the rooms being used for? How much cooling are you going to need? How much heating are you need? How are you going to do your dehumidification? And so to get the most out of the use of using CHP, you want to balance what you're getting from the plant in terms of heat. You want to use as much of that as possible, because that's going to increase your overall efficiency of the system and bring down your overall cost to operate. So finding that balance between what the mechanical engineer is doing and how the systems are being laid out and how you're implementing CHP, they're different problems, and looking at different aspects of the overall design, and they're not necessarily aligned. You have to align them, and it might take several iterations to find the right balance. For instance, if you're thinking, the bigger you make your CHP plant and the bigger generators and engines you have, the more capital costs you might have driving that up. So you may want to bring down that size as small as possible. Well, if you're saying, if you want to pull more and more off the generators and want to just power like a chiller with your heat or something along that lines with an absorption chillers, you may have shrunk down the CHP to a point where the heat you're producing from it is only going to produce not the amount of cooling you're going to need through absorption chiller or something like that. So then you would have to end up upsizing on your generator side to produce more heat, or to provide power to electric chillers, or possibly use Tecogen chillers as well. So it's a tricky problem, really, because it's a chicken and egg type problem where you're starting, and it really takes iteration and coordination with the team, and also the amount of power that's available at the site to begin with is another factor kind of weighing into that. So as you move along the design process and kind of dial in and answer those questions, there's several other coordination items. I'm sure I'm going to miss some of them here, but just to point out a few. Redundancy is another thing, both redundancy on the the generator side, the power side, as long as with your HVAC systems and the chillers. So finding that right balance, as well as like how that power system is being started up, because you might need to make temporary provisions for starting up on the HVAC side before the power systems are necessarily ready, because those lead times are happening at different times. So yeah, not only through the design but through startup, redundancy control is another big item. I think control just in the CEA space is confusing in general. Like you have the fertigation side, you have the HVAC side, and then when you put in CHP, you're adding that in as another control point and another point where you might have to interface. And sometimes the controls provider can do all of that, but oftentimes that's not the case, and you need to make sure that those issues are covered. So that you're getting the right controls provider involved. So yeah, there's a lot of coordination points, not only with the mechanical engineer and the CHP provider, but all the other trades and engineers, as you kind of alluded to. So it's important to have good communication across the teams, and make sure that communication is going forward to the entire cycle of the project.
Yeah. It means, again, it doesn't have to be complicated for the owners, right? You're working with a group of people that kind of understand what all these challenges are and the things that you've got to work through. But it's a process, right? And there's a lot to understand. Kind of touching on the controls and automation systems, one of the challenges that we've experienced, not just when we implement CHP systems, but really in any cultivation facility, is that the controls systems that are kind of marketed and designed for cultivation facilities tend to lean, for the most part, and there's some exceptions, but for the most part tend to lean pretty heavily toward kind of an enable disable, right? Just turn it on, turn it off, without a lot of programming or modulation, or what happens when there's a sequence of events that has to take place, right? And that's when you get into more of a real building management style system. And so a lot of times folks don't consider, they just think that they can just kind of implement this simple on-off system, which tells them what's happening with their lights, or if they've got what their temperature set point is. But there's really a lot more to that when you get into these more sophisticated applications, right? Where we've got a lot of moving parts and a lot of things that have to happen to keep everything working together. And so that controls conversation is an important point.
Yeah, for sure. And I've spent a lot of time commissioning in my career, where you're in the field, you're at the end of the project, and you're trying to get things started up, and really passing that design intent along through the process is, no matter how simple you try to make it or write it down or whatever you're doing, it can get it tends to get confused as it moves from one party to the next. And so within Surna, we have a controls group, and there can even be confusion there passing along design intent. So it is important to understand that not all controls providers are equal. They might be good at one thing and not another. Coordinating a CHP plant with perhaps a complicated chiller system and hydronic systems along with air handlers can be a notch too much for some of them. So it's careful to consider that, and then make sure that the design intent is communicated and that the engineers are working together to make sure the system's ultimately going to operate the way you want it to.
Early on, we were faced with working with, let's just call it the good friends, the Dutch, which are very much analog types of horticultural controls, to which you had to put a BMS, or building management system, on top of that. So there are now control providers, including people on this call, that are trying to basically integrate all of that together. And that makes life so much easier. Plus, as you said, Brandy, you're not always in a 1-0 situation. You're in a very controlled situation. So the world has moved quite a bit, since 2015, when these facilities really first started coming up.
Yeah. And again, we don't say this to say, oh, this is a huge problem. It's just one of the things that you've got to be aware of, right? If you're considering the implementation of a type of system like this. So I want to switch gears just a little bit, and sorry, just to go back again, super high level here, guys, hitting on some major points. There's a lot more information available to you if you want to go do a deeper dive. I want to switch gears just a little bit, and this question is for you, Steve. It sounds like for this to really benefit you need this kind of really large scale cultivation facility, right? And folks that are maybe operating smaller facilities maybe aren't thinking that this is the right solution for them. Do you agree with that line of thinking, or do you think that smaller cultivators can benefit from implementing CHP?
Yeah, that's a great question. I think just to give everyone some perspective, our average customer size in indoor cultivation probably operates somewhere between 15 to 25,000 square feet of canopy, right? And all those customers are benefiting from our CHP systems, whether it be electrical based system generating some of their power, which we've talked a lot about, or maybe more mechanical approach where we're generating their chilled water with natural gas, recovering heat. So yeah, I think we have systems that scale down quite small. So I think, again, as long as people have sort of chosen that pathway of hydronic 4-pipe system, even if you have, 200 or 300 ton cooling load, you could still benefit from CHP. And the systems tend to get easier as they get smaller. The permitting gets easier. For example, we're exempt from an air permit in a lot of places due to the size and cleanliness of our engines. So it kind of, obviously, as you get bigger, it gets more complicated. But I think as you get bigger, it gets even more critical to consider too. So, but I think most people should take a look at it. There's micro grows and things like that probably won't be a fit, but by and large, most of the people out there could benefit from this. And I think most people have utility rates that are conducive to it. Certainly there are exceptions to all that, but
yeah, it's worth a look, right? And really in almost any situation. So so guys, we have about 7 minutes or so before we need to jump to the Q&A. I've got quite a few of them that came in, and I want to try to get to as many as we can. So just kind of I skipped a little bit of the subjects that I think we wanted to talk about, and I'm not sure we're going to have time to circle back to them, but I did want to make sure that we talk about, is a group that's seen a lot of CHP and a lot of mechanical systems, a lot of cultivation facilities in general. Seen a lot of successful projects, but we've also seen cultivators who've kind of made mistakes, right? And the idea is to educate everybody to the degree that we can to help them avoid some of the mistakes that we've seen made in the industry. So, you guys want to talk on that subject, some of the things that you think are maybe some pitfalls or things to look out for when folks are considering these things? See, we can start with you since.
Yeah, I think related to the question I got earlier about the tax incentives, I think we've seen people not research that well enough ahead of time, consult with their tax attorneys to make sure, especially in cannabis, the right business entity is getting involved in the ownership of that asset. Again, got to watch out for 280E. So you just got to proceed with caution and make sure you're not rushing into a purchase potentially with the wrong business entity that is touching the Schedule I drug, and you could run into issues with the tax benefits. So,
well, and I think that too, you touched on this to some degree before, but with vegetable, and indoor food producers, a lot of times they're kind of going, well, I'm not going to make money the first year. How am I going to take advantage of this tax credit? But understanding that they can effectively sell that tax credit, right, and generate cash against that purchase, that's a pretty big deal, and something that you would have to be structured in order to take advantage of, right? So
absolutely.
What about you, Jim?
I'm going to go through a little bit of things that they need to think about when they're putting their team together and their approach to growing together. Okay. And so that's kind of a best practices approach. Okay. Very clearly for indoors, chillers are a major part of best practices. Okay. 4-pipe or thermal dehumidification using the heat. So when I did a Tecogen system back in 2015, we did thermal desiccant dehu. Okay. But it's still using the heat from the thing. One of the things we saw, and Kenneth kind of touched on it, is in every indoor grow right now, we are using all the heat just for heat dehumidification and temperature controls. Okay. there's not enough heat left over for absorptive chillers. Okay, so absorptive chillers work very well in some of my other applications, but in indoor growing, they have not. Okay. Positive pressure in the room. So make sure your designers are working towards positive pressure and considering CO2. So CO2 is a dollar trade-off. Okay. As CO2 has gotten more expensive, the use of your own CO2 is making more sense, but it does add some complication to the whole process. On the greenhouse side, you have to be very high tech. You have to be high gable. So you have to have two growing environments, okay? A growing environment by the plant and your exhaust growing environment. You need positive pressure in greenhouses, okay? You know, typical low-tech greenhouses don't lend themselves to this very well. And you would like airflows basically coming in at or underneath your benches to get your CO2, your heat, and everything else closer to the plant as opposed to trying to blow it into the facility. Then you get into what I call the preferential side of best practices, and that's LEDs versus HPS. That's drip and aeroponics versus hand watering. That's different types of high-tech media versus dirt, okay? Controls, moving to more automated BMS systems versus just normal horticultural controls, and automation, especially in greenhouses. You know, you need to basically take as much cost out of it and put it into front end costs. Okay, so that's really just a starting point. And if you don't think you can grow like that, then you're going to have a hard time of, you know, swallowing CHP.
Kenneth, what about, I agree, and thank you. That was enormously helpful. Kenneth, what about you? You know, do you see sometimes, I mean, sometimes we get plans from cultivators that they ask us to review or take another look at. You know, what do you see sometimes, or some kind of common issues?
Well, I would say in general, you know, whether it's a smaller project or a much bigger project, you know, these types of a CHP system is going to most likely, it's going to add upfront capital, it's going to add complexity, and it's going to add more partners to execute the work. So anytime, you know, you're adding factors like that into a construction project, you know, there's going to be more opportunity for mistakes, and you know, when those mistakes are made, they're going to tend to cost more to remedy during the construction phase. I'm more talking about like if you miss a coordination item. So I would say, you know, it is important to get the team in place, which is representing, you know, the CHP, the engineers, MEP engineers, you know, and other building consultants, working together from an early stage, when major decisions are being made for the direction of the project. You know, an owner or operator might come into contact with an engineer first, or a CHP provider first, architect. You know, there's any number of ways they might, you know, start having these conversations about a facility. But when you're moving into CHP, if you go too far down the road with any one party without understanding these coordination items, you know, it just could be kind of setting you up for a lot of rework or remaking decisions that you thought you already made.
Yeah, I agree. I mean, we say this a lot, even without even CHP, right? Do not make decisions in a vacuum, right? Meaning have the team in place, and I'll give you a great example. Sometimes there are CHP providers in the world who are just so used to providing absorptive chillers or using waste heat to power absorptive chillers that they just kind of automatically say, this is what you're going to do. Well, then you get your mechanical engineer who has cultivation facility experience involved, and they go, that's probably not the best idea in this application, right? But the decision's already made, and the money's already spent, right? And so that's just kind of one of those examples of how it's really best, you know, to make sure that you implement folks that have this direct experience, but also that the team is working together and coordinating it as a team, right? To make sure that you're really getting the best system design and that you're not spending money where you don't have to, right?
Yeah.
Is pretty important. So do you guys have any last thoughts before we move on to the Q&A? Anything else that you'd like to add that we missed? No?
I would just echo the importance of getting the right MEP team. I mean, as CHP manufacturers, that's the first question we ask an owner is, who's your MEP team? And then we're trying to gauge how difficult our job's going to be to help the project go smoothly. And if the MEP team knows what they're doing, like you guys, then, you know, we're in good shape, I think. So.
Well, that's kind of you to say. We've done it a few times by now, kind of seen a lot of stuff, but you know, and we would say the same thing, right? The expertise of all of the different contributors is just so valuable, and you're as strong as your weakest link, you know, as everyone says. So it's important to make sure that everyone really knows what they're doing, to make sure that you guys as owners really take advantage of the really significant benefits of CHP. So I'm going to just kind of dive into a few of these questions. One of the first questions we had really early on, what's the combustion efficiency of burning natural gas? Jim, can you speak to that?
So from our standpoint, we use large commercial engines, and basically engines that have been in the world of horticulture for a long time. So on the electrical side, you're going to see efficiency starting at about 36% and going up as high as 47%. Okay. Clearly the middle range, the 40%ers, are going to allow you to have a lot of the ups and downs that you see in a horticultural facility from a load standpoint, as where the ones that are 46% efficient, those are basically what we call a Miller cycle engine, almost a single speed engine without the flexibility to load follow. Okay. And then typically from Kenneth's standpoint, we can easily add 35+% of thermal usage to add to that efficiency. So we're going to be kind of starting off in the 80 to 85% efficient before we really start tweaking the systems.
Got it. We had another one. We actually had a couple of questions around this, and that was around the use of CO2. Is you know, can we produce enough to supply enough CO2 to the facility? And B, what does that kind of look like, right? What kind of infrastructure do you need in order to capture and reuse that?
From our standpoint, it all comes down to emissions controls. The level of emissions controls is what allows you to capture CO2. So you have to have something that's totally clean, because everyone on this panel and all of you are going to be in that room an awful lot. So you want the cleanest potential environment that you can get. So you have to work with people that are very efficient at emissions controls. Stephen's product have a fairly a more simplified approach to emissions controls than larger CHP engines, but you just need to have somebody that understands that whole permitting and control process to get the CO2. And then you've got to deliver the CO2 into the room. And that just adds to Kenneth's problem because it's a mechanical problem.
So generally through ducting and some kind of an air distribution system, right?
Correct.
Yeah, and that's something that CHP providers can help you quantify, right? What that kind of payback period is, or what that savings might be, right? A use versus purchasing CO2 new, which really just, it seems kind of like buying a dog instead of going to the shelter, right? We're just going to dump this CO2 out and go buy new, clean, pretty CO2, as opposed to, you know, cleaning up what we're already making and distributing that to the facility.
And then real quick, Brandy, to every situation, any CHP setup can deliver more CO2 than the facility will require.
Thank you for that clarification. We have a couple more. Looking at kind of sizing CHP systems, is there a general rule of thumb, just really high level around power requirements against square footage or facility size? Is there something that you guys have found that again has to be engineered, but just a back of the napkin?
I think it really depends on if you're trying to solve electric capacity constraint with CHP, right? Because if you're doing that, you could end up with a much larger CHP system than you would if you were just sizing it for best economics, right? I think if you don't have electric capacity problem, you're really sizing the CHP in such a way that you're utilizing all of its outputs as much as you can. So generally, you're limited thermally on how much reheat the facility can use and that sort of thing. And then you basically get as much electricity as you can get from that system, and it's going to cover some percentage of your total electric use. So that's kind of how we would go about it. I don't know if Jim has anything to add on that, but
yeah, so smallest system, well, it matches up very closely with your systems because it is one of your systems. That was 20,000 square feet and around 300 kW, okay? As you get smaller in size, redundancy gets to be a problem because you never want to be operating these situations on a single engine. And then basically, there are some metrics as to basically megawatts per square foot for either a greenhouse facility or an indoor facility. And you always design it as if it is off grid. And then if you get power from the grid, you're in even better shape.
Got it. Two types of engines generally, right? The turbines and then the reciprocating engine. We've got a question from one of our attendees about the use of turbines as opposed to reciprocating engines, and has anyone used a microturbine for a cultivation CHP system?
Yes. I don't recommend it, but yes. So we'll talk to a situation because someone got in there and sold a turbine because of its small footprint and its ability to deliver lots of heat. And so therefore it was delivering heat to absorptive chillers, okay? First off, the best microturbines are in the 30 to 31% efficiency range. So that's fairly critical from a cost of operation. That particular facility also put in absorptive chillers, then all of a sudden realized they had used all their heat for cooling. They then had to come back in their design process and add in massive amounts of boilers for, to do the heat and the reheat. Yeah. And so therefore, they were sold something by somebody who wanted to move in a certain direction. So yes, it's a very small footprint. It is very well attuned to using heat.
Got it.
What about Jim on that partial loads as well? Don't the reciprocating engines function better in partial loads?
Much better. They're good point, Ken. You can run engines down to 50% and not really lose it. You like it 60 and above. A turbine really wants to be in that 80-100% operational range.
I think one other thing people forget too is that the turbines are rated at 59 degrees ambient. So anytime you get above that, you're going to have power derate and you're going to have efficiency derate. So a lot of people don't take that into consideration.
That's a good point.
They also derate fairly quickly at altitude. And since, I began in the world of Colorado and we were at altitude, turbines just don't perform well.
They have their application, maybe not ideal in a lot of the cultivation applications. Something that we do a pretty good summary of in the white paper as well, if you guys want more information there. I love this question. This is the last one from the Q&A, and then I'll hop over to chat if we have any more time. Maintenance. I would include maintenance as one of the mistakes that a lot of cultivators make, not just for CHP, but really in their entire facility, as really not accounting for a person who's specifically skilled at facilities maintenance. That's something that's going to be really important in any cultivation facility, and doubly important when you're using really sophisticated systems, right? What kind of maintenance costs are we looking at with CHP on the engine maintenance? And it's different between turbines and reciprocating engines, but in general.
Yeah, I think Jim's guidance he provided earlier is pretty accurate. It's anywhere from 2 to 2.5 cents per kilowatt hour. Is a pretty good number. So you want to make sure you're accounting for that when you're thinking about your total cost of generation.
And that's an expertise, right? Your grower's not going to be able to run out there and maintain your engine, right? This is something
Right.
that you've really got to allow for when you're doing your business plan and your facility planning, right? And your hiring.
Yeah, you want to make sure that your provider has a means to help you get the system maintained either from themselves. Tecogen has factory maintenance programs, but getting someone in there lined up at the right cost and the expertise to do it. Definitely not something you want to try to self-perform. I mean, growers should be focusing on growing plants profitably and not repairing engines and that sort of thing. So leave it to the experts.
So I'm gonna, sorry, Jim.
To that point, real fast, Brandy.
Yeah, I think we're just about out of time, aren't we? Oh, shoot, we might want to switch over.
Run.
Yeah, we've got 1 minute left. Is there a price per kilowatt where your threshold generally sits, or does that vary? Where it really makes sense to switch over to CHP?
Clearly, it goes up as they get smaller. Okay. So, let's just say medium to large scale, you're looking at $1.30 to $1.50 per watt for install. If you go all the way up to tri-generation, you're probably $1.60 to $1.70 per watt, okay, for initial installation.
All right, well, that's our time, guys. Isabel's going to put up a slide with our contact info. If there's anyone that we didn't get to, please feel free to email us. This is the link to where you can download the white paper. If you guys hop on there, you can download it for free. If you have any questions at all, if you want to reach out, if we can help you with facility design, or if you just want to kind of follow up on some of the questions that we might not have gotten to, feel free to contact any of us. Our email addresses are on the screen.
I just want to pop in and say one final thank you to Brandy and to all of our panelists today for this discussion. It was very interesting and very needed. And thank you for your time. And we'll call it a day. Everyone have a great one and take care.
Thank you all so much.
Thanks.
Bye, guys.
Thanks, everyone.